Hello, I'm back with another malware analysis video, and this time I want to take a look at Gh0stRAT. Now, I'm here on Malware Bazaar, and you can see the sample that I'm using has these hashes, and you can just download this right here. Now, I was looking for some malware to analyze that I found interesting a while back, and Gh0stRAT was part of a huge cyber espionage campaign, so I decided to have a look at it. And when I first got started with this, I came to realize that the payload component of Gh0stRAT is actually encrypted or obfuscated in this executable. So I really wanted to get to the payload. And this is something that when components are, let's say, hidden this way, that I always struggle a little bit with. So I was able to extract this payload, and I thought this might be interesting to other people as well. And that is one of the reasons that I'm making this video. So here I am in Gh0stRAT. I imported this sample. Don't mind the name up here. I just renamed it. And first of all, I started looking for some kind of a main function, some kind of an entry point. So of course I went to entry first. And here I was a little bit disappointed because I didn't find anything. Here with this last reference, you can already see an annotation that I did. And yeah, at this point, I had to start digging. I couldn't find anything of use to me or immediately of use. No nice main function or something. Nothing that just stood out or something. So I went on the search, and what I did was, in the first step, I looked at the imports here. Now, in the imports, there are, as you can see, quite a lot of functions, but not all of these are interesting. So, first of all, I went after everything that allocates memory. So this virtual alloc here, then there is a heap alloc up here, and I couldn't really find anything that was actually interesting. So then I had a look at the sleep, and here was the first indicator that I found that I think was a little bit strange. So let's just look at this. Now, these cross references here are this handler, as you can see, this catch down here, and also this address. So when I jumped here, I actually found this undefined function, and I think that this undefined function was actually found, I will just show you real quick, by just enabling this aggressive instruction finder. So I came here, and what I immediately saw was this XOR. So I was under the impression that there might be something that is obfuscated or encrypted via XOR. There is this sleep that actually got me here, and the sleep 0 I also found a little bit strange. So this was one of the first things that I just made a note of, that there seems to be something going on right here. Now in here I was interested in who actually calls this, or where is this called from. So for that I used these cross references and just jumped back. I came to these blocks, to these handlers, and I just went along these cross references, and eventually I came to another undefined function, and from the cross reference there I came to a function that was decompiled without this aggressive instruction finder that had this label in here. So this is what I called end reference. Now, once I had this, I went ahead again and just checked the cross references. So I went from this cross reference and eventually where I landed was at this last reference with this label here that is called in the entry function. where I annotated it. So this pretty much showed me that eventually this malware will come to the point where it gets to this XOR function that I saw. Now, if you look at this function, the decompilation result is not that nice. Now there's this unaff EBP, and there are actually ways to fix things like this, but to be honest, at this point, I just said to myself, let's load this up in a debugger and go through it step by step and see what happens and when we come down here and what is actually XOR'd with what. I just loaded this into the debugger and then I set a breakpoint right here at this address. Now, if I run the program, then I end up here. Now, from this part, I just stepped and wanted to see what would happen. And eventually, I ended up first here, where I got this shell X string. But that wasn't all. I also found another string, this A3F0D. Now, that was also something that I found quite interesting. Now next, I just kept stepping through here. And then here we are at this address where I set the breakpoint. And here you can see the sleep with the timeout of 0 milliseconds. Now I'm just going to make the register view a little bit larger so it's easier to see. And then I'm going to show you a couple of things that are happening here. Now down here you can recognize this XOR instruction, and what was interesting for me is what is calculated here. So what is in this DL and what is in this AL. Now if I just step through this right here, you can see that this ASCII string, this A3F0D that I saw before, is actually here in EDX. Now stepping a little bit further, you can see something else, and that is this address right here, this 40A040. So now when we look here, we can also find this address, and it's right here. So this 1, 2, these are the first 2 bytes of this block. So now I'm back in Ghidra, and down here I just jumped to this address. Now I wanted to see next, where is this referenced? And when I scrolled through it, I saw this was a huge block of data. Now let's just check out these references real quick before we continue in the debugger. I don't want to go to this reference here, I want to go to this one instead. This part of the memory is referenced at this end reference, and here is this number, and when I did a little bit of calculating with an hex editor, I saw that this memory area has this size right here. So now let's go back to the debugger and have a look what happens here, or at least what I was able to find out. So I'm going to step again, and here we can see these 2 values are loaded to ECX and EDX respectively. And now if I just continue on down to this XOR part right here, then you can see that this 1 that was in here was replaced by 32. So because of the size of this area in the memory and these references to it and also this XOR, I was pretty sure that this was the actual payload of the malware. The next thing that I did was I just pulled this encrypted block of data out from the executable, and you can see that here in my hex editor. Then I went back to Ghidra and then I reversed this routine using the disassembly. So in the end, I got to this very, very simple decryption routine that uses this key string that I found and then XORs it with the buffer. Now, the only thing that is a little bit counterintuitive, if you just take a look at this +1 right here, the decryption starts with this key byte, not with the first one, but the second one. And that's pretty much the only thing that you have to look out for. And then, once this ran through, I had a file with the decrypted payload. So after I ran the decryption, I got this as an output. And here's already the string, this program cannot be run in DOS mode, which looks pretty good to me. And if you just come down a little bit, there are functions. And here there are more strings, some Windows versions. The only problem is this 21 right here. So at this part of the file, there should be an MZ, like here in this executable. Here I just edited this in the hex editor per hand and replaced this 32 and 31 with an M and a Z. And then I got the payload, which I then checked in the terminal. So now I'm back here on the command line, and I just renamed this extracted binary to Gh0stRAT payload DLL. And if I run the file command on it, it is recognized as a DLL here. If you import this to Gh0stRAT, it's automatically recognized as a portable executable with this x86 32-bit little endian for Windows. And then if you say OK here and do the analysis, now I'm going to enable this aggressive instruction finder and just click Analyze. We will just wait until this completes, and then we're going to look a little bit at the symbol tree, at the imports and things like that. So when the analysis was finished, I immediately found myself at this DOS header. The functions in the symbol tree contain an entry again, of course, and from the imports there are quite a few functions in here to take a look at. Some of them are of course more interesting than others. Here, for example, is this get asynchronous key state, which just suggests a keylogging component. And when I looked at the strings in this DLL or this executable, I found some indicators for keylogging. Of course, this is a Trojan horse, so that's probably something that it's meant to do. And at this point, I'm gonna stop the video. I haven't done any deeper analysis on this. I only imported it to Gh0stRAT and checked if everything seems okay or not. So if you got this far, I just want to say thank you very much for watching and see you again next time. Goodbye.